Remember that if you have a point and you have a line and you want to find the shortest distance between that point and the line, basically what you do is you choose a point on the line called S, and you figure out the vector between S and your point. And there's going to be a variable in there. And then you're going to take the scalar product of that with the equation for the red line, and then you're going to figure out when that's going to be perpendicular. Okay, so first we're going to say uh, what is the vector for our red point to point S? Okay, so we'll call that vector small s. Okay, so small s is equal to this point, which we don't know exactly where it is, but we know that it's on the line, so we'll use the equation for the line, 1 plus 2t, negative 1 plus 3t, and 2 plus t. Okay, so that's the point S. And then we're going to subtract the coordinates of our red point, which is 1, 1, 3. And that will give us a big mess. So it'd be 1 plus 2t minus 1, so it'd be 2t for the x coordinate. For the y coordinate, it would be negative 1 plus 3t minus 1, so it'd be negative 2 plus 3t, or actually it'd be, negative 2 plus 3t. And then the z coordinate would be 2 minus 3, so it'd be negative 1 plus t. Okay, so that's the vector s. And so we're going to see when vector s is perpendicular to vector this line. But to do the scalar product, we don't need the position vector. All we need is the direction vector. So we're going to take the scalar product of the direction vector times this. So it's going to be here, it's going to be 2t, negative 2 plus 3t, and negative 1 plus t. Okay, and then we're going to do the dot product of those. So we're going to get 4t plus 3 times 3t minus 2 times 3. And then we got t minus 1 times 1. And so we get 4t plus 9t minus 6 plus t minus 1. And so this, we're going to combine like terms. We get 4t plus 9t plus 1t is 14t, minus 7 is equal to 0 because we want the whole scalar product to equal 0. And then we know that 14t equals 7, so t is equal to 2. Okay, so if t is equal to 2, then we know that the coordinates we were looking for right here for, no, not there. The coordinates right for this here, we just plug in 2, and then we get the coordinates. So 1 plus 2 times 2 is 5. Negative 1 plus 6 is 5. And 2 plus 2 is 4. So that is the answer to A, where it's asking what is the point S, the position vector S. So it's 5, 5, 4. Okay, that's A. B is asking the shortest distance from the point to the line. The equation for the point to the line is that one. So all we need to do is plug t equals 2 here. And then we're going to get, for B, we get 2 times 2 is 4. We get negative 2 plus 3 times 2 is 6, so 6 minus 2 is 4. And then we have 2 minus 1 is 1. Okay, so that is the answer for B. All right. So, basically what we did was, for part A, we found this point. And for part B, we found this distance. Okay? 13F, Intersecting Lines, page 335 reading. Okay. Triangle ABC is formed by 3 lines. Line 1 is, and then it gives it, line 2 is this, line 3 is that, where R, S, and T are scalars. Draw 3 lines accurately on a grid. Let's see. This is going to be a challenge. Let's try it. The first trick is let's draw the grid where it should really be. And I'm not sure yet, but let's guess. Okay, so first line, line 1, we're going to have -1 and 6. So -1 and +6. 1, 2, 3, 4, 5, 6. So it's there. And then the slope is x would be +3 and y is -2. So it would be +3, -2. So it would be like that. That. Okay? All right. And then that was line 1. Let's do line 2. So line 2 would start at 0, 2, right there. And then it would slope 1, 1. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay. Now we'll do the next one. Line 3 starts at 10, -3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -3. Okay, -3. And then the slope is, let's see, -2 units of x, and then 3 units of y. Is that right? -2 units of x and 3 units. Okay, yeah. Oh, so the triangle is actually going to be up here. That kind of surprised me. So there's a triangle. All right, ABC, which we can do just by examining the graph. So like, for example, A would be 2, 4, B would be 8, 0, and C would be 4, 6. Okay, and then it says to prove that the triangle ABC is an isosceles triangle, and we can do that by using the distance formula, right? Remember the distance formula? It's just like Pythagorean theorem, basically. It's the square root of x1 minus x2 squared, I'm sorry, minus x1 minus x2 squared plus y1 minus y2 squared. Okay, and so like for example, if we want to find the distance AB, we would do 2 minus 8 squared plus 4 minus 0 squared, which would give us square root of 36 plus 16, which is equal to square root of 52, right? And that would be AB, distance AB. Okay, and then if we want to know the distance BC, we would do 8 minus 4 squared plus 0 minus 6 squared, or 6 minus 0 squared. Since it's squared, it doesn't matter which order, which is also equal to 16 plus 36, which is square root of 52. So we just proved that using the distance formula that AB is equal to BC, so it's an isosceles triangle. Then it says to use vector methods to check your answers to B. First thing we're going to do is we're going to make vectors out of the points BC and AB. So for example, BC, we're going to take the vector B minus the point V, B minus the point C, and we'll make it a vector out of it. So 8 minus 4 is 4, 0 minus 6 is -6, so we've made a vector out of it, okay? And I don't know, maybe I did it in the wrong order, but it doesn't really matter because all we're going to do is figure out the magnitudes anyway. What about a to b? So we're going to make a vector out of this. So 8 minus 2 is 6, and 0 minus 4 is negative 4. So that's another vector. Okay. So, and now that we have these two vectors which represent two sides of the isosceles triangle, we're going to find the magnitude of each one, and the way to do that is using the distance formula. So square root of 4 squared plus 6 squared, and then the other one happens to be the exact same thing, right? Square root of 4 squared plus 6 squared. So they are also the same. Okay? Moving on to number 3. Okay. So those are both square root of 52. Alright, now we got an isosceles triangle ABC formed by these three lines, AB, BC, and AC. Okay? And we're going to use vector methods to find the coordinates A, B, and C. Okay, so for example, we'll take first AB and BC, and then we'll figure out when those two lines intersect to find the point B. Okay, so first we're going to try to find B. So we're going to take the x-coordinate, which is for AB is x equals 0 plus 2r. And we're going to set that equal to the x-coordinate for BC, which is 8 minus s. And then we're going to make another equation with the y-coordinates. So for the y-coordinates, we have y equals 2 plus r for AB, and we have y equals 6 minus 2s for BC. And now we have two equations and two unknowns, and we're going to solve for r here. So 6 minus 2 is 4 minus 2s. And then we're going to put 4 minus 2s into r here, and we'll get 2 times 4 minus 2s equals 8 minus s. We got 8 minus 4s equals 8 minus s. So the 8's cancel out, and we end up with minus 4s equals negative s. The only way that's true is if s equals 0. Okay, so s is equal to 0. What about r? If we put s in for s here, then we have 4 minus 2, 0 is equal to 4. So r is equal to 4. Okay, so those are the magic numbers to make the first two lines intersect with each other. And if we want to know what the coordinate is for B, then we just plug in r equals 4 or s equals 0 into one of these. S equals 0 is easier. So we're going to take the BC equation, and we're going to say, okay, 8 minus s is 8 minus 0, so the x-coordinate is at 8, and then the y-coordinate would be 6 minus 2s, so it would just be 6. Okay, so we know that the B coordinate, the B position vector is 8, 6. Okay. Now let's work it out for coordinate A. So if we do coordinate A, we're going to use these two equations. And so the first one is going to be 0 plus 2r, and that's equal to 0 plus t. And then the y-coordinate would be 2 plus r, which is equal to 5 minus t. And so now we plug in t equals 2r for this one. So we have 2 plus r equals 5 minus 2r. And so now we have 3r is equal to 3, so r is equal to 1. If we know r is equal to 1, then we know that t is equal to 2. So now we can find, using r or t, the coordinate for A. So let's see. We'll use this equation here. So we use t equals 2. So the x-coordinate for A would be 0 plus 2. And the y-coordinate for A would be 5 minus 2, which would be 3. Okay? Last of all, let's find C. So for C, we're going to look at that equation and this equation. So let's see, AC says that the x-coordinate is t, and BC says that the x-coordinate is 8 minus s. And then for the y-coordinate, I'll write it here. And for BC, the y-coordinate is 6 minus 2s. Okay. And then now let's substitute in t equals 8 minus s for here. And then we'll get 5 minus 8 plus s. And on the right side, we'll have 6 minus 2s. And then we'll have 3s on this side, and we'll have 9 on this side. So we know that s equals 3. And if s equals 3, then t is equal to 5. And then so if we want to find out the coordinate of C, then we can put t equals 5 into here. So the x-coordinate would be 5, and the y-coordinate would be 5 minus 5, which is 0. Okay. So our three coordinates would be here, here, and here. And it says which two sides of the triangle are equal in length. Find all side lengths. So let's see. Let's see, we'll find AB. Vector AB is going to be equal to 8 minus 2, 6 minus 3, which is 6, 3. And so the magnitude of 6, 3 would be square root of 36 plus 9, which would be square root of 45. Okay, that would be the magnitude. And then let's find AC. AC would be 5 minus 2 and 0 minus 3. So it would be 3, negative 3, which would be a magnitude of 18, square root of 18. And then there is BC, which is equal to 5 minus 8 and 0 minus 6. That would be negative 3, negative 6. And the magnitude of that would be square root of 45. And ding, ding, ding. That matches with that, right? So isosceles triangle. We found it. Okay, and that was the end of page